Okay, we're going to go ahead and decide to talk a little bit about the material, not just to solve problems, but this is the last unit of the year. We're going to find out whether we have to do it this way the rest of the time. But this is a physics based on basics of electric circuits. So I'm going to define a quantity, talk about the symbol, units, and definition before we get to actually setting up some circuitry. The first quantity we're going to talk about is voltage. That's we give by the letter V. The unit for that is the volt, which is also with a V. And definition for that would be the difference in electric potential. So if you want to write that down. And what we mean by that is we said that you could separate charge in different ways, but if you had a way to do it constantly, like in the case of, say, a battery, then we would say that the positive up here would have high potential and the low potential would be on the negative side. And from that, you could have electrons flow, or what we call current, which is the next thing. We're going to find out in a little bit an equation for this, but the joule per coulomb of charge, a joule of energy per coulomb of charge is a volt. Okay. The next thing you'd like to define is electric current. Current is given by the letter I. The letter I is going to be measured in what we call amperes or amps for short, which is an A. And that's just known as the amount of charge passing a point in a given amount of time. So that moves in time. So from what we've talked about before, charge is given by the letter Q, so that would be the charge over the time is the current. So if you think over here in units, this is also the number of coulombs per second is what an ampere is. Okay? All right. We'll go on for that and define a couple more things. If we just go on from that, the next thing I want to define is the term resistance. Certain materials have what we call a resistance. We're going to use R as the letter for that. The unit is the ohm, O-H-M, and that's given by a symbol which is the Greek letter sigma, capital letter. And that's the ability of a material to hold back the flow of charge, to resist charge flow. You might say, well, how does that work or whatever? Well, in, say, a wire, we basically have a material that has a certain length, and maybe we might say a cross-sectional area even. So it's got some area and some length. The resistance is equal to rho L over A for that material. Rho is called the resistivity of the material. I'm just going to read off a couple for you. Resistivity of, say, silver is on the order of 1.5 times 10 to the negative 8. Copper, 1.7 times 10 to the negative 8. So something like copper wire, 1.68 times 10 to the negative 8. The units for that ohm meters. and aluminum is somewhere around 3 times 10 to the negative 8. All right. When we look at this, there will be an equation that says V equals I times R, and R then would be equal to V over I. So when we look at units, a volt over an amp is referred to as an ohm. That's what an ohm is. Okay. Also, in terms of resistivity, which might be interesting to note, is that that's sometimes known as the reciprocal of what we call the conductivity. You would expect many conductors, metals, to have high conductivity. That would be true. So that's the reciprocal of that. So it's a very low resistivity and a very high conductivity. Last thing we want to talk about is power, electrical power. We're going to use the letter P just like we did in mechanics. If you remember, the unit for in power is the watt. That's just the rate of energy transfer, just like we said before in mechanics. The equation for that would be the power is the change in energy over a certain amount of time. We said last semester work over time, but that's the same thing as a change in energy. Now, how does that relate for all these variables we just used? Well, the power is the current times the voltage for a material. So just as a repeat of some of the equations that you might need to know for this unit, power is current times voltage. Voltage is current times resistance, better known as Ohm's law. Current is the change in charge, or the amount of charge that passes a point in a certain amount of time, delta Q over delta T. And then the resistance is rho L over A. Looks like I used all of that piece of paper. Hope that was useful. Stay safe. We'll talk more in a while. Thanks.